Welcome back, everybody. Today we're looking at solving and graphing two-step inequalities. Now before we get started, if you need to have a little bit of a refresher on solving one-step inequalities, please go ahead, watch that video just to give yourself an idea of how everything works. If you're ready to go, then what we'll do is, like I tend to like to do a lot, we're going to compare solving a two-step equation with solving a two-step inequality. So let's go ahead and get started and let's see what we can do. So first we're going to solve a two-step equation. So let's look at the equation 2m minus 5 is equal to 7. Okay? So we have 2m minus 5 equals 7. Now remember, when we solve a two-step equation, the first thing that we try to do is we try to eliminate the constant that's on the same side of the equation as our variable. So if we're looking for our variable, it's the 2m, or rather the m, the 2 is the coefficient, and our constant is negative 5, and that's the value that we try to eliminate as our first step. So to eliminate a negative 5, we are going to use the additive inverse, and we're going to add the inverse of the value that we have in our equation. So we're going to add positive 5 to both sides of the equation. When we add negative 5 and positive 5, we get a 0, or a 0 pair. So those essentially cancel each other out, and we can ignore that for the remainder of our problem. So we have 2m, we bring that straight down, equals, and then we have 7 plus 5, which is 12. Our next step in solving a two-step equation is to use the multiplicative inverse, which means we're going to multiply both sides of the equation by the reciprocal of our coefficient. So our coefficient is 2 over 1. If we turn that into a fraction, it makes it a little easier to see. So our coefficient is 2 over 1, and we're going to multiply both sides of the equation by 1 over 2. And the reason that we do that is when we multiply by 1 over 2, on the left-hand side, we get a value of 2 over 2 when we multiply, 2 over 2m, which we know turns into a 1, and we don't need to write that as part of a coefficient, so we just write the variable m. On the right-hand side, we're going to have 12 times 1, which is 12, and 1 times 2, which is 2. And 12 over 2 we can simplify to a value of 6. So our value for a two-step equation would be m is equal to 6. So the next thing we're going to do is we're going to compare that using the exact same numbers to solving a two-step inequality. So let's go ahead and rewrite our problem, except this time, instead of writing it as equals 7, we're going to use less than 7. Okay, so we have 2m minus 5 is less than 7. As is often the case when we compare inequalities and equations and the methods of solving them, the steps are essentially identical to each other. Our first step with solving an inequality, a two-step inequality, is, just like with equations, we're going to use the additive inverse. We're going to add 5 to both sides of the equation so that we can eliminate the constant of negative 5. Negative 5 and positive 5, just like in our previous example, will give us a value of 0, so they essentially cancel each other out. 2m we still need to bring down as part of our problem. We have our inequality of less than, and then we have 7 plus 5, which is going to be a value of 12. So as you can see, everything so far is the exact same as solving a two-step equation. Just like with solving a two-step equation, we are going to multiply both sides of the inequality using the multiplicative inverse. Remember, we like to multiply by the inverse of the coefficient. Our coefficient is 2 over 1, so we're going to multiply by 1 over 2. It's reciprocal. When we multiply by 1 over 2, on the left-hand side, we're going to multiply across, and we'll end up with 2 over 2m is less than 12 over 2 on the right-hand side. So far, everything is identical to solving an equation. Our next step is to simplify. So we have 2 over 2, which of course becomes a 1, which we don't need to write. We just write it as the variable m. The 1 as a coefficient is just understood to be there. We still have our inequality of less than, and we have 12 divided by 2, which is 6. So as you can see, solving a two-step inequality is identical in this instance to solving a two-step equation. Now there is one difference, and we're going to get to that in just a second. Oh, almost forgot. This is an inequality, which means usually we need to be able to graph the values to give ourselves a visual representation of what's happening in our problem. So we're going to create a quick number line here. Oops, that's a 6, not an 8. So we have our number line, and remember that the first thing that we have to do is we have to figure out where exactly on this number line do we start. And that's found by looking at our inequality. M is less than 6, so 6 is our starting point. We start with an open circle until we decide whether or not 6 can be a value that answers this inequality. So if we put 6 in for m, we would have 6 is less than 6, which does not make sense. It's not equal to, so we don't fill in our circle. We have m is less than 6, which means we are going to draw our arrow to the left, giving a representation that any value that is less than 6 will answer this inequality correctly. So the next thing we're going to do is we're going to look at solving a two-step inequality that the answer comes out slightly different than what we would get when solving a two-step equation. So let's go ahead and erase the screen, and then we'll get started on that next problem. So when I say that the answer comes out slightly different, what I'm really talking about is the way that we solve is a little bit different, and really there's only one difference, and we're going to see that pretty quickly once we start solving. So let's solve a two-step equation again, and this time I'm going to change one of the values. We'll use essentially the same problem that we did just a second ago, but this time we're going to say negative 2m plus 5 is equal to, and we can pick any value that we want. We'll just say 13 this time. So the setup is basically the same. The biggest difference, aside from the 5 being positive and 13 not being 7, the difference that I want to highlight for you is that the coefficient of m in this case is a negative number. And that doesn't mean anything for equations. We solve them identically whether there's a positive or negative coefficient, but remember that it does change the inequality. So let's go ahead and look at the equation. First off, we're going to eliminate positive 5 because we don't like to have constants on the same side as our variable. So we're going to eliminate positive 5 by adding negative 5 to both sides of the equation. When we do this, we are going to eliminate the 5 by using the additive inverse. We get negative 2m is equal to, and then 13 and negative 5, if we combine those or subtract or add negative 5 and 13, then we end up with a positive 8. Our next step would be to use the multiplicative inverse. So we're going to multiply both sides of the equation by the reciprocal of the coefficient. So our coefficient is negative 2 over 1, so we're going to multiply both sides by 1 over negative 2. And when we do this, on the left-hand side, as always, we find that we can essentially eliminate the coefficient, so we're left with just m. And on the right-hand side, we're going to have 8 times 1 and 1 times negative 2, which gives us 8 over negative 2. So our final answer would be that m is equal to negative 4. Now, as I said, solving a two-step inequality this time is going to be a little bit different, and the difference comes because the coefficient is negative. And hopefully you remember this from our previous lessons, but if not, that's okay. We're just going to go through it again really quickly, and we'll figure out what we have to do differently. So the first thing we're going to do, just like we did with the equation, is we're going to eliminate the positive 5 as the constant on the left-hand side of the equation. Remember that our goal is to isolate the variable, which means we need to get rid of the 5 and the negative 2. So we're going to add negative 5 to both sides. It's the additive inverse. And when we do that, we're going to end up with negative 2m. The 5's cancel each other out, give us 0, so we just don't worry about that. 13 minus 5 is positive 8. Oh my goodness. I just realized I wrote this as an equation, so we're just going to change this to less than or equal to. I know it's kind of cheating, but that's the way life is sometimes. So we have less than or equal to 8. Our next step is going to be multiplying both sides of the inequality by the reciprocal of the coefficient. That's the multiplicative inverse. That's what we're going to use. So we're going to multiply both sides by 1 over negative 2. And here's the part that you need to be careful of. This is the difference between this example and the previous one. First off, on the left-hand side, you'll notice that we're still going to be able to eliminate the coefficient of m, so we're left with just m. On the right-hand side, we're going to have 8 over negative 2, which is still the exact same. But remember, here's our difference. When you multiply both sides of an equation by a negative number, the inequality changes and faces the opposite direction. So instead of less than or equal to, we're now going to change it to m is greater than or equal to 8 over negative 2. And then, of course, we would simplify our last step, and we would have m is greater than or equal to negative 4. So really, the only difference between the two is that when you do have a negative coefficient of a variable, then the inequality changes directions, and that's the only thing that's different between solving a two-step inequality and solving a two-step equation. Lastly, of course, we would graph this. So let's go ahead and do that. We're going to have our graph. We'll put in our values. Let's go by 2's again just because it's a little easier. So negative 2, negative 4. We have positive 2 and positive 4. So when we look at this problem, we start, as always, with the value that we have in our problem, which in this case is negative 4. So we're going to put our circle there. Next, we determine whether or not negative 4 can be an answer. So if we put negative 4 in for m, we're going to have negative 4 is greater than or equal to negative 4. And that makes that true because negative 4 is equal to negative 4. So that means we're going to fill in our circle, and we're going to have that as one of our possible answers. The next step would be reading this and seeing that m is greater than. That's where the rest of our answers are. So greater than values, anything greater than negative 4, is to the right of that point. So this is how we would solve and graph two-step inequalities. And remember, most important thing in today's lesson, as was with the one-step inequalities with multiplicative inverse, is the fact that if you have a negative value as your coefficient of your variable, when you use the multiplicative inverse, you change the direction of the inequality. Very important. That about wraps it up, so good luck, and we'll talk some more tomorrow.